A spacecraft descends and lands on the rocky surface of an asteroid.
Bennu was visited by a spacecraft called OSIRIS-REx, which is a NASA spacecraft.
Helena Bates, museum scientist, standing in a lab.
One of the words in the acronym of OSIRIS-REx is security, and that is because technically Bennu is the most dangerous asteroid in the solar system to Earth. There is a small, very, very small chance that in the early 2180s, Bennu might impact Earth. And one of the reasons why we say might, and we don't know for certain, is because there is a very small effect that happens to small bodies, which is when the sun shines a light on the asteroid, and then the asteroid rotates a little bit, and then that light is emitted, and that kind of acts like a little bit of like a rocket kick, and it moves it ever so slightly, and its orbit changes. And we really can't quantify that without knowing exactly what the asteroid is made of.
A scientist holds up a sample of very fine, dark-coloured asteroid dust.
So the Bennu samples are going to be able to tell us exactly what the sample is made of and what the asteroid is made of. So we'll be able to really, really constrain that very small effect, which obviously over a long period of time builds up to a very large effect. So hopefully the analysis should tell us whether Bennu will impact us in the future, but it is a small asteroid, so there's nothing to worry about.
A view from space showing the Earth, the Sun and the Moon.
So at some point in the next century, the asteroid is going to pass between the Earth and the Moon. And obviously passing through the Earth and the Moon, those big gravitational bodies are going to affect the orbit slightly. So once that's happened, and also once we know exactly what Bennu is made of, we should be able to really constrain that risk. And if there is a risk, the risk increases, there are ways of dealing with it. We've recently had NASA's DART mission, where they sent a spacecraft up and they crashed a spacecraft into an asteroid, and they managed to change its orbit. When OSIRIS-REx arrived at Bennu, we were really surprised to see how loosely it was held together. We expected there to be areas of it that were much more consolidated than it was. And we found that the surface was covered in boulders, and they were only kind of loosely on the surface of the asteroid. So when the spacecraft descended to the surface, the sample arm actually penetrated 50 centimeters into the regolith. The regolith is basically the surface layer of a material that's covering an asteroid. It's normally very fine-grained dust. And the theory is that if we hadn't fired the return thrusters, that spacecraft would have just gone the whole way through and would have just gone out the other end of the asteroid. So that was really, really surprising to us because the other asteroids that we'd visited in the past were much more consolidated than Bennu was. In terms of it potentially impacting, obviously, yes, if it's very loosely held together, it's very likely that if it does hit Earth, it will break up into lots of smaller pieces, thereby reducing the overall risk.
Credits over a picture of an asteroid dust sample.